about dose rate. What does dose rate determine? I think I already gave this away. Dose rate determines your CSS average here. I don't know why, I just pretend that isn't there, that CSS min. For some reason, when I copied this graph, it only copied that. And anyway, dose rate determines, it's the only thing we control, determines your CSS average. What else determines CSS average? Well, you see dose rate there. I like to think of CSS average so that, because I am going to expect you to know this equation, because you're going to use it so much that you will know it. I think of it as drug in over drug out. Drug in, we control with dose rate, right? But if that drug does not have 100% bioavailability, you also have to consider, you all know what bioavailability is, right? You also have to consider what fraction of the drug is actually going to make it to the systemic circulation, right? So it's your bioavailable dose rate. That's drug in. Does everybody get that conceptually? Because I really prefer if you don't have to memorize a whole bunch of stuff, but actually understand it. So drug in, bioavailable dose rate, over drug out, which is clearance. Clearance is key. Key. So what will make changes in CSS average? Well, if there's a bioavailability change, if the bioavailability goes up, what's going to happen to your CSS average if everything else stays the same? The whole curve is going to go up, isn't it? Your CSS average and the whole thing is going to go up. And vice versa if it goes down, right? What happens if your clearance changes? What if the drug is cleared by the kidneys and suddenly your clearance goes down? What's going to happen to your whole curve? I'm sure you didn't even need to come to lecture today to talk about that. So if your clearance goes down, what's going to happen to the CSS average? Everybody? It's going to go up, right? Because you're not eliminating the drug. And vice versa, if you have a patient with kidney failure and suddenly that improves, what's going to happen to your whole curve? Going to go down. Both of those could be good or bad, right? We don't control that situation. What do we control in that? Our dose rate, how much drug we give per time. Not dose, but dose rate. So the only thing we control is dose rate. But we can use dose rate so that if these things happen, if our bioavailability or clearance changes, we can anticipate that or recognize it and change our dose rate to accommodate, right? So I don't know if you can see that little line, but there's your CSS average. This is, again, kind of depicting what I showed you on the big graph before. So your CSS average is your area under the curve at steady state between 0 and tau. So it's this area under the curve divided by the time to give you this average concentration. So this just shows you these are computer generated graphs that I made that shows you, God bless you, the effect of changing your dose rate. So if we look at 200 milligrams given every 6 hours, which is this more bluish purple, right? What we see here is our CSS average is 2.1. Our Cmax is 2.8. Our Cmin is 1.5. And the peak to trough ratio is 1.9. Okay? If we go from 250 to Q6 to 500 Q6, what have we done to our dose rate? We've doubled it, right? We've doubled our dose rate. What have we done to our dose interval? It stays the same, right? So all we've done, the only thing we've done is doubled the dose rate. We're going to assume no other changes happen in the patient. Okay? So what do we expect to happen? What do we know dose rate has an effect on? CSS average. So what do we expect to happen to CSS average? Well, it'll double, and sure enough, it goes from 2.1 to 4.2. Our Cmax is 5.6 and our Cmin is 3, but our peak to trough ratio is the same. Would you have expected that? Maybe you haven't thought about it, but all we're doing is double the dose rate. So what would that have to do with the slope of your elimination curve? What determines K? Okay, this is a really important point. I'm going to hold it, though, for a minute. Okay, so we wouldn't expect peak to trough ratio to change, and it doesn't. So when we double a dose rate and keep the interval the same, we basically are hoisting the whole curve up, aren't we? If we have the dose rate, the opposite would occur. You good? When do we want to change dose rate? This is just kind of a little thing you can think through. The first thing I always think of, and this I want you to train your brain to go through because it will help you a lot going forward. You may not think so right now, but trust me, it will. You ask yourself, is CSS average where I want it to be? Is the CSS average where I want it to be? If it is, you leave that dose rate alone. If your CSS average is too low, guess what you do? You increase the dose rate. If it's too high, you decrease the dose rate. This is not hard, right? But this is what I want you to remember, that you might forget in the time of a quiz or a test or the time when you're really stressed out. Do I want to change the dose rate? I will ask you this many, many times in different situations. And I want you to train your brain to think, is CSS average where I want it or not? And then work from there. Even if the beak is in the toxic range? Right. Okay, dose interval.